Hi everyone and welcome to AXA Arctic Live. My name is Jamie and today we are going to do a little bit of science together to look at our live investigation about an acid Arctic. We're going to do a few things today together. We are going to have a look around outside where we are. We're going to talk about some of the science that we've been doing up here over the past 10 years or so. We're also going to touch on some basic subject knowledge. So what is ocean acidification? What is this thing pH? And that's going to be followed by two investigations. The science skills that we're going to be using are predicting and observing with a little bit of measurement thrown in. And we're going to be doing two investigations that are really simple. You can do them in the classroom, you can do them at home. And as we work through this, you'll see they're using pretty common items that you can get from a supermarket or shop. So plenty of opportunity to join in this ideas around Arctic science, some of the changes that are going on up here. Before we get into the lesson proper, a few things to go over, a bit of housekeeping. You will see that there is an interaction box beside the video screen. You can do a number of things here. You can post questions. So any questions you might have, both about life in the Arctic in general, and also anything that we've been going through, please post those questions in there. You can also upvote questions, and this increases the chance that we'll answer them. And lastly, this is also where the polls will appear. There are a couple of polls just to get you thinking about those two science skills I mentioned at the beginning, predicting and observing. If you've got any technical issues, please do click on the green chat icon at the bottom right of every page, and we'll try and keep those separate. So any questions or shout outs that you have, get those in the chat app. Any issues that you have, click the icon at the bottom to contact technical support. So without further ado, I'm just going to introduce you first of all to the location where we are. We'll have a look outside and then we will look at some of the science that we've been doing over the past years. So we are in the UK Arctic Research Station, and that is in the settlement of Ny-Ålesund on the island of Svalbard. And Svalbard is halfway between the top of Norway. Technically it's an archipelago collection of islands, but it's halfway between the top of Norway and the North Pole. So North Pole that way, Norway that way, and about 1,200 kilometers in either direction. North Pole, 1,200 kilometers that way, not much in between us and there, and then the sort of mainland Norway down the other way. I'm just going to give you a bit of a show around. It's always good to see the Arctic environment on Arctic Live. I have to say, as we head outside, that the murk has set in. From being quite a nice day earlier on, it's actually got into a fairly horrible day now. I'm just going to open the door to where we are at the UK station, step to one side so we can get the camera out, and then just describe what you can or cannot see. Looking out, we have, first of all, looking back, you can see down the side of the station. Then panning across, we can see some of the accommodation, especially those are London houses. Those were built before the First World War, moved over here from the other side of the fjord just after the Second World War, and that's accommodation for visiting scientists and support staff. If you can see through the snow, it's a bit of a murky day today. If you can see through the snow, you might just see that dark water That's the fjord where we've been doing our research. The first ocean acidification research I joined up here in 2014, and then most recently sort of 2018, 2019. Foreshore, we quite often see some reindeer on this area here, and as it melts into the summer, you'll probably get quite a few nesting wildfowl, so that's sort of ducks and geese coming up here and nesting up in this region. At the moment, we don't probably need any of you on polar bear watch. None have been seen round the settlement in recent weeks, but as the weather warms, we might see them coming over from more of the interior, more over onto the sort of more icebound east coast, hunting for seals, and then coming over here and feeding on the wildfowl as they come back. Now, Ellie, who's got the camera, her hands are looking pretty raw, so she's going to come back in, set up again, and we'll introduce you to what it normally looks like or can look like in some of the research that we've been doing over the past years. I'll give Ellie just a moment to set up again. We're all wired in here. No wireless up in this settlement. Any wireless signals interfere with the scientific work that's going on. So we're just going to sort of have a look at sort of what it's like to go out and research on the fjord when the weather's a bit nicer. So it's essentially being out in a boat, a small research vessel, the Teaston, and that's going out. And really for the ocean acidification work, we've been looking at two things over the years, one of which has been looking at the pH of the water, and the pH is the unit that we use to measure acidity. So the way that you do that is you put collecting bottles called Niskin bottles over the side at different points around the fjord, and then collect water at different depths, bring it back, and essentially bring it back and measure the pH of that. There are other things to think about to make sure that that measurement, in looking at its impact on krill, and then most recently looking at its impact on where a variety of different types of sea life might settle. So where they would prefer to live, and what the different pHs, how that affects their choices at different depths. It's quite a strange area we'll come on to later, because we've got a mix of all the ice melting, that's fresh water mixing with seawater, so we get these different waters, and that can affect the acidity as well. So I just hope you've enjoyed those shots where we've been and what the research has been like. And we're going to move on to the sort of first of the next sort of three stages before a Q&A section. The first section is really talking about two things. It's talking first of all about pH, and then the process of ocean acidification. We're then going to come to our first investigation. We're going to predict and observe a mini ocean and what happens when we add a gas to that mini ocean. And the last stage is just observing what might happen to a chalky substance, a calcium carbonate substance, when it is in an acid solution. So we're just going to go over those two important bits of subject knowledge to help you access these two investigations. The first is pH. And pH is the scale that we use to measure acidity. So we've got it going from 14 all the way down to 0, with 7 kind of in the middle. We call 7 neutral. It's what water, fresh water is pH 7. Getting lower, you get into the sort of lemons, tomato, all the way down to battery acid territory, including vinegar. We're going to use vinegar for today's live investigation. And then go upwards, you've got the detergents and bleachers going in higher pH, less acid, and also called alkali. So even if we're going from a pH 9 down to a pH 8, that is something getting more acidic. Okay, so it's like the temperature scale, insofar if it's 30 degrees and goes down to 25 degrees, even if it's above our sort of neutral point 0, it's still getting colder. So today we're going to be talking about things becoming more acidic, and that is a lower pH. So that's just something to get your head round. If there's any follow-up questions on that, please put them in the chat. The second process we're going to talk about is this ocean acidification idea. It's sometimes called climate change's evil twin, and it is also driven by increased carbon emissions in the atmosphere. And what we see is that carbon dioxide in the atmosphere, CO2, chemical formula, some of you may be familiar with chemical formulae, that CO2 is absorbed into the ocean, and we have CO2 plus H2O for the water, H2O being the chemical formula for water, and that, through a chemical reaction, becomes carbonic acid, H2CO3, as the chemical formula. So this process, there's some more complex science which we can go into later. This process, essentially we're saying more carbon dioxide in the atmosphere, more carbon dioxide in the ocean, and that is forming an acid. Now, looking at this over time, we've seen a decrease in ocean pH from a global average in about 1750 of about 8.2 to about 8.1 in present day. That will vary around the world. Lower pH is probably in the Arctic, as we can see that there's more CO2 is able to dissolve in these colder waters. But the first investigation we're going to have a look at is to see whether this idea of adding carbon dioxide to an ocean, whether this has an impact on its pH level. So what you're going to need for this investigation are three things. First of all, you're going to need a mini ocean, not too full. So this is just tap water in a container. You're going to need a straw, and you're going to need something to measure the pH with. That could be an electronic pH meter. It could be some litmus paper that I'll be using, and the color changes depending on the pH of the liquid you put it in. Or you could use a natural pH indicator like red cabbage boiled up and using the water from that. Now, the idea is, our hypothesis is, that if I blow through a straw into this mini ocean, the carbon dioxide as I exhale, as I breathe out, will dissolve into this mini ocean and will cause a change. Or will it? So what we're going to put on the screen now is a poll for you to vote in. And there are three poll options. and we want you to predict what might happen. The first option is that the pH of the ocean will decrease, i.e. get more acidic. The second option is that the pH of the ocean will stay the same. And the third option, the pH of the ocean will increase, get less acidic. And just as you get ready, get your equipment ready, we'll time a minute shortly, think about what you predict will happen, and then at the end, we'll look at what you observed happening. I'm just going to get ready myself. Hopefully you're getting ready too. Fantastic, and we'll come back to some of those predictions in just a bit. So Ellie, who's behind the camera, will give me a starting point, and you can all join me in adding carbon dioxide to our mini ocean.
3, 2, 1, go. 30 seconds, halfway. Ten, 5, 4, 3, 2, 1, and stop.
Amazing, amazing, amazing. I hope you had a good time doing that too. What we're going to do now is I've got some of the same water that we started off with, and I'm just going to measure the pH of this. I'm going to compare it to the water that I've just bubbled through. So here we are. I'm going to dip this into our non-blown through water. There we go. And then tear another piece off, and this is our blown through water. This is going to take a little bit of time to react. And we'll leave those there for a bit. So great to see. I'm predicting that because I've added carbon dioxide to my mini ocean, that we're going to see a change. I'm expecting to see a sort of greeny, sludgy colour for the water that had not been blown through, and then for the water that had been blown through, I'm expecting to see more of a yellowy colour. And I'm just going to hold up the pH scale so you can just get a sense of the changes I'm expecting. So you can see we've got reddish for a very low pH acidic, all the way through yellow, green to sort of purpley colour for very alkali or less acidic, a higher pH. just as we wait for that to happen, I'll sort of take you through sort of what we have experienced over the past sort of 250 years. So at the sort of start of the Industrial Revolution, 1750, pH of about 8.2, down now to sort of ocean average of about 8.1, and potentially down as low as sort of 7.8 by the end of the century. Now, even over the past 250 years, that decrease of a 0.1 of a unit of pH may not sound like very much, but it actually represents a 30% increase in acidity. Now, if that happened in your blood, a 30% increase in acidity, you would be straight to hospital, straight to ER, and very, very rapid surgery happening or care happening just to keep you alive. That would be a life-threatening level. What we're going to look at next is why changes in ocean pH matter to some of the living things in the ocean. We're going to do this using a few common objects, and what we're going to do is we're going to place a bit of chalk in a beaker, and we're going to add some vinegar to it. The reason why we do that is because a lot of creatures in the ocean have chalky or calcium carbonate skeletons or structures. Some up here might be like a clam and other crustacea. Not clam, not being a crustacea, but sort of mollusks and crustacea. Also, the coral reef, using a calcium carbonate structure. So plenty of marine organisms using calcium carbonate to grow their skeletons or structures. What we've been seeing already, and also more in experiments using projected ocean pHs, is that the calcium carbonate reacts with an acid. Now, living organisms aren't just lumps of chalk. They're alive, and they will, even with a slight increase in acidity, they will be working hard, trying to build up their shells. And we've got pictures of some pteropods that we can show working hard. But as the pH decreases, that hard work may not be enough. The shells may get sort of brittler, they may get thinner, they may get a little bit pitted. And even if they can still build a decent shell, they're using up a lot of energy that could otherwise be used for growth, for reproduction, for movement, for finding food, all those different types of things. I'm just waiting for my litmus paper to show a good result here, and we'll just wait for a little bit longer. Probably need to dry out a bit more. So what we'll move on straight on to is this second investigation. I've just got a few things. I've got some vinegar. It's super strength pickling vinegar from up here. So I'm just going to wear some glasses in case there's a bit of a splash. There we go. Sting a bit if it gets to my eye. I'm going to put some chalk to represent our animal, and I'm going to add some vinegar to here. I'll just move these over and perhaps move this a little bit further forward so we can get a focus in on that, and then just add some vinegar to this and we can observe what happens. That's pretty strong. Straight away, we can see this bubbling, this reaction between the acid, the vinegar, and the chalk. This is not what we're seeing in the world's ocean at the moment. But again, as I said, even the fact that there's a slight change in pH and there's more stress going on can cause an issue for life that has a chalky structure or skeleton. So, ocean acidification is really about this sort of climate change's sort of evil twin. It's this change of ocean pH, which is putting a stress on a lot of life that lives there, especially a lot of life at the bottom of the food chain, the sort of plankton. And even if we're not going to see this, put my foot in the sea, it's an acid bath, it's all going to dissolve away. Not what we're looking at, but we're looking at this making life tougher for a lot of life in the ocean, and having to put more energy to building the structures and shells rather than putting that energy into growth, reproduction, finding food, those kinds of things. So overall, and I'm still waiting for my wonderful litmus paper here. Overall, what we've been looking at today is we've been looking at two things. First of all, I'm going to leave it here to dry a bit more. First of all, we'll be looking at this idea of pH, and that is the unit we use to measure acidity. Second, we've been looking at the process of ocean acidification. Hopefully, won't get too many vinegar splashes from this distance. Look at the process of ocean acidification, how adding carbon dioxide to our mini ocean changes its pH. We predicted it would change its pH, the acidity would increase, the pH would decrease. Our litmus paper is lagging behind in the cold at the back of the studio here. And then we're looking and observing at the impact of an acid on our chalk and our pretend sea creature. Thank you so much for being part of this live lesson on ocean acidification. It's been fantastic to have you all with us. Don't forget to join us tomorrow when we are looking at sea level rise, and then on Thursday when we are looking at caring for the Arctic. Until then, it's been wonderful to have you with us. Thank you so much again, and it's goodbye from Arctic Live. Goodbye.